What's up, Matrix? Your time has come. It is 6 o'clock and we're ready to do maths for you. I am Luni and with me is Natasha. Natasha, how are you doing today?
I'm very good, Luni. Thank you so much. And should I tell them what they're doing
Yes,
today?
you can tell us, please.
All right, so grade 12, so we're carrying on with calculus. Remember last week we just introduced the whole concept of calculus and deriving by rules and by first principles. So today we're going to carry on with finding the equation of a tangent. So I think while I make my way over to the board, Luni's going to tell you how you
know
can
your
get...
cue, you know everything.
Absolutely.
All right, you can
I'm
go to your board then. Matrix, while Dina's at, Natasha, is at her board, I'd just like to tell you guys, facebook.com/LearnExtra is where you can get us on Facebook. On Twitter, we are at LearnExtra, that is our handle. And you can download all your show notes, the schedules, and the videos, and past papers, guys, on learnextra.co.za/live. So interact with me, ask me any questions you may have, and we're both here to help you out. So I'll take it straight to Natasha for the lesson.
All right, guys, so as I said, last week we did a little bit of calculus. We looked at limits, deriving by rule, and first principles. So today we're carrying on with calculus. Obviously, calculus is a major section in grade 12, and it's worth the bulk of your marks in your final exam. So a very important section. And today we're going to look at finding the equation of a tangent using calculus. All right, so you were introduced to the concept of tangents in grade 11. Some of you may have forgotten what a tangent is, so we're going to go over it from the beginning. Let's get started. Okay, so as I said, today we're going to look at finding the equation of a tangent. We just need to remind ourselves what a tangent is. So a tangent is basically just a straight line that just touches the curve at a point. Now, if you have a look at the drawing I've got here. All right, so I'm going to just try and correct it because the line is not really in the right place, so just bear with me. Okay, and I'm just going to delete it, guys, and I'm going to redraw it because that was not quite a tangent. So if you have some curve, right, and a tangent will be a line that's drawn to the curve and it just touches it, just barely touches it, grazes it at a point. Okay, so as you can see on my drawing, at that point there, the line, the straight line, the tangent just touches the curve. All right, tangents, very importantly, are normal straight lines defined by your straight line equation, which is y equals mx plus c. And very importantly, this is a concept that you will use all the time in grade 12, is that a tangent to a curve will have exactly the same gradient as the curve at the point of contact. So if you look at our drawing where this cubic graph meets the straight line, the tangent, the gradient of the tangent is going to be equal to the gradient of the curve. So the gradients are the same at the point of contact. Okay, that's incredibly important. That's a concept we're going to use throughout today's lesson. So if you don't understand that concept, please let Luni know and I'll go over it again. Okay, but I think some of you would have already started using that concept, right? The tangent to the curve at the point of contact has the same gradient as the curve. Okay, the best way to do any of this is by looking at an example to show you what we mean. Okay, how do we find the gradient of a curve? Hopefully you're all shouting at your screens and hopefully you all know the answer. You find the gradient of a curve by deriving. Okay, remember we learned how to derive last week. So another reason we need to derive, I remember I went over all the different reasons that you need calculus and you need to derive and that, but another reason you need to derive is to find the gradient of a curve. So how do you find the gradient of a curve? You derive. Okay, let's look at the first example. So here we are asked to find the equation of the tangent to f of x is equal to x squared minus 2x plus 1, which is a parabola, at the point minus 1 and 4. Okay, so what do they want? They want the equation of a tangent. What is a tangent? It is a straight line that just touches a curve and it has the same gradient as the curve. Okay, so if we're finding the equation of the tangent, we really need to find the equation of the straight line. Okay, let's have a look. I'm going to draw this for you so that you have an idea of what we're talking about. So we've got a parabola, x squared minus 2x minus 1. All right, and we are told that a tangent touches this curve at the point minus 1, 4, and they want to know what the equation of this tangent is. Okay, so that's our tangent, and this point of contact is minus 1, 4. Okay, what do they want to know? They want to know what is the equation of this line. Okay, so graphically, this is what they're asking you to find. Okay, the equation of the straight line that just touches the parabola. Okay, how do you do it? Guys, if remember, if you're trying to find the equation of a straight line, you need two things. You need your gradients and you need the y-intercept. Okay, if you're going to use the formula y equals mx plus c. So you need your gradients, you need your y-intercept. Your gradient is given by m and the y-intercept is given by c. Now, all you're given in this question is you've got the equation of the parabola, you have the points of contact. That's it. So you've got to use that information now to try and find the equation of the straight line. How do we do it? Okay, this is where calculus comes in. So we know that the equation of the parabola is y is equal to x squared minus 2x plus 1. We also know the point of contact is minus 1 and 4. Okay, the first thing we're going to do is to find m, the gradient of the tangent. How do I do that? Remember that the gradient of the tangent is equal to the gradient of the curve at the point of contact. Okay, so at the point of contact, they are equal to each other, both gradients. So I need to find the gradient of that curve, and the only way we can do it is by using calculus. I've got the equation of the curve, I need to find the gradient, so in order to find the gradient, I need to derive. So remember, I use y prime to show that I'm deriving, and I'm going to just use my rules for deriving. So I'm going to say 2 times x, so I bring the power to the front, multiply by 1, so I get 2 times 1 is 2, and then from the power you subtract 1, and 2 minus 1 is 1. All right, then the next term, minus 2x, is just going to give us minus 2, because the power of x is 1. 1 times minus 2 is minus 2. And then from the x, the power is 1. If we say 1 minus 1, we get x to the 0. And anything to the power of 0 is 1. So the x will just fall away because it becomes x to the 0, which is just 1. The derivative of any constant, we did that last week. The derivative of a constant is 0, so we leave that term out. All right, so this is the general form of the gradient of this curve. With this, I can find the gradient at any point on the curve. So this will help me to find the gradient at any point. But I'm not interested in just any point. I'm interested in the point minus 1 and 4. So if I want the gradient, I'm simply going to use the x coordinate of the point of contact, and I'm going to substitute it into my general gradient formula. So I'm going to say, put in the minus 1 in place of the x, substitute it. Let's see what we get. 2 times minus 1 is minus 2. Minus 2 will give me minus 4. Okay, so therefore the gradient at the point minus 1, 4 is equal to minus 4. All right, so this gradient of minus 4, remember, is exactly the same for the parabola and the straight line. Why is it exactly the same? Because it's the point of contact. And we know, and I'm going to keep on saying it over and over as the show goes on, and you might get tired of it, but it's an important concept. We know that the gradient of the tangent is equal to the gradient of the curve at the point of contact. So therefore, the gradient of the tangent will also be -4. Okay, so let's go back to our diagram and let's see what we found. All right, so we found that this parabola, at that point, the gradient was -4. So therefore, the gradient of the tangent must also be equal to -4. So in y equals mx plus c, we now can replace m with -4. All right, so we now get y is equal to -4x plus c. All right. To find the coordinates of c, which is the y-intercept, all you can do, or all you need to do, is substitute your point of contact, which is -1 and 4, in place of y and x, and then you solve for your y-intercept. All right, so I've got y is equal to -4x plus c. I'm now going to substitute the coordinates from the point of contact. So I know y is 4 and x is -1. And I'm going to solve for c. So I get 4 on the left-hand side is equal to -4 times -1 is just 4 plus c. So therefore, c is equal to 4 minus 4, which is 0. So therefore, the equation of my straight line is y is equal to -4x. Okay. Some of you might not like to use that method to find the equation of the straight line. That's fine. You can also use y minus y1 is equal to m times x minus x1. What you would do there, and I'm not going to go through the whole thing because you're going to get the same answer, is you're going to substitute y1 and x1 as your coordinates, and m you'll substitute as -4. Okay, and then in place of y1 and x1, you'll substitute your coordinates -1 and 4, and you can also find the equation of the straight line that way. Either way, whether you use the y-intercept method or you use the coordinate and the gradient method, you'll still get the same answer for the equation of the tangent. All right, and I think it's about time to take a break, Looney.
All right, before we take a break, I'd like to read a comment from Kimberly. She says, as a student, I would love to thank Mindset Learn for helping me pass my matric with flying colors. I'm still proud of myself, but I don't understand why they don't have Mindset Learn for university students. I learn very quickly when I see someone doing something. And with all the lectures not being like school teachers, I bet lots of other students need Mindset Learn. Do you have anything to say about that?
Well, I'm glad that she has such faith in Mindset Learn and she learns so much from the show. That's fantastic. I think the problem with university, and I mean, I'm just speaking on my behalf, I don't know what the channel's views are, but I think the problem with university is you don't have a lot of people doing maths at university. Maths is kind of the subject that people would rather stay away from. So I think that might be the reason, but good luck with the studies.
Yes. Another thing I say to Kimberly is that in university, people try to make you be more independent. So like, unlike teachers, your lecturers aren't going to feed you all the information that you need to have. Your lecturers are going to make you go research and go do things for yourself. So Mindset Learn is there for you until grade 12, and then when you reach grade 12, you have to find your independence and you have to just find your feet and do things on your own. So thank you so much for that comment. And with all that said, we're going to take a very short break, guys, so don't you go anywhere. Welcome back, grade 12s, from that very short break. I hope you guys are enjoying calculus. Well, most of you say you're enjoying it, so I'm very glad that you guys are having fun. I did post the link to our show notes, so if you guys can go on Facebook, you'll find it there, and some more information of everything that you'll need for the show. So without wasting any time, I'll take it straight back to Natasha.
All right, thank you so much, Lenny. So guys, carrying on with our lesson on finding the equation of a tangent. Just to recap what we did before the break, the most important concept for you to take out of that is that the gradient of the tangent is equal to the gradient of the curve at the points of contact. Okay, and that's what we're going to use to look at this example, well, this question, the first question. We are told that the line y is equal to 11x plus 44 is a tangent, so that means it just touches it, to the curve, and they give you the curve. Okay, it happens to be a parabola again, and then they ask you to find the point of contact. Okay, so let's kind of get an idea of what's going on here. I'm going to make a rough drawing. And you don't have to make a drawing every time. I'm just doing it now to get you used to this idea of the tangent to the curve. But once you know what's going on, you really don't have to draw this all the time. All right. Remember, your tangent is just touching your curve, so it's not supposed to hit it at more than one point at the points of contact. All right, so that's our point of contact there. They want to know what that point of contact is. They tell you that the equation of the parabola, they give it to you, is minus 2x squared minus 5x plus 12. And they tell you that the equation of your tangent, remember it's a straight line, is y is equal to mx plus c. So y is equal to 11x plus 44. So obviously this question is slightly different from the last one, because in the last one we were given the coordinates, we needed to find the equation. Now we're given two equations and we're asked to find the point of contact. Okay, so some of you might think, well, if I have a graph, two graphs intersecting at a point, I can use simultaneous equations to solve. Okay. In this case, it will work and you'll be able to do it, okay? Sometimes the questions get quite complicated and quite long-winded and you don't want to be doing simultaneous equations. But if you now at this stage spotted that you can do simultaneous equations, yes you can. But for the purposes of this lesson and for the purposes of you really getting to grips with calculus and understanding how to use tangents and curves and that kind of thing and gradients, we're not going to use simultaneous equations, we need to use calculus. Okay, so we're going to stick to the calculus concept. So we know that this line, 11x plus 44, is a tangent to the curve. So therefore, we know that the gradient of the tangent must be equal to the gradient of the curve at the point of contact. All right? And that's going to help us to find the point of contact, because we can see that the gradient of the tangent is 11, because remember it's y is equal to mx plus c, so therefore the gradient must be 11, right? So easy to find the gradient of the tangent. We can find the gradient of the curve also very easily by deriving. At the point of contact, the derivative of the curve, which gives me the gradient, should be equal to the gradient of the straight line, which is 11. So what that means is that all I need to do is find the derivative of the curve using calculus and then equate it to the gradient of the tangent. Okay, so let's have a look. Let's do that. So I'm going to find the gradient of the curve by deriving, using our rules for deriving. So it's going to become minus 4x. The power of the second term is just 1, so it's going to be minus 5. And then obviously the derivative of the constant is 0. So therefore the derivative of the curve is minus 4x minus 5. But remember, this derivative of this curve is not just the derivative of the curve, it's got a special name. It's called the gradient of the curve. So therefore this gradient of the curve, minus 4x minus 5, must be equal to the gradient of the tangent at the point of contact. So I know that the gradient of the tangent is 11. So if I've got two things that give me the same answer, that means I can equate them. So therefore minus 4x minus 5, which is the gradient of the curve, must be equal to the gradient of the tangent, which is 11, and this is going to help me to solve for x. So I've got minus 4x is equal to 11, take the 5 over, it becomes positive, 11 plus 5 is 16. Then divide both sides by negative 4, and I get x is equal to negative 4. Now to find the y value, I can either take this x value, substitute it into the equation of the straight line, which is 11x plus 44, or I can substitute it into the equation of the parabola. Remember, they'll both give you the same answer because at the point of contact, they have the same coordinates. I'm going to use the straight line. So we've got y is equal to 11x plus 44. All right. And all I'm going to do is I'm going to substitute x is equal to negative 4 and see what the y value is. So I'm going to get 11 times minus 4 plus 44. 11 times negative 4 is negative 44. Negative 44 plus 44 is 0. So therefore the point of contact is minus 4 and 0. Okay, so on your drawing, the point where they're meeting, that point there, is minus 4 and 0. Okay, I'm just going to quickly go over it again, okay, just in case any of you are lost. Okay, so here what we were given was we were given the equation of the tangent and we were given the equation of the parabola. You were then asked to find the point of contact. So what we did is we said, well, the gradient of the tangent must be equal to the gradient of the curve at the point of contact. All I did was then I found the gradient of the curve by deriving. I then equated that to the gradient of the tangent, which was given to us, and through that I found the x value, took that x value, substituted it back into the equation of the straight line, and that gave me the point of contact. Okay, it's actually much quicker than trying to do simultaneous equations. Okay, a really nice, quick, easy way to do finding the point of contact. Okay, before I carry on to the next question, I just want to see with Looney if you guys are all following.
Okay, Lita is asking, can you please go through the tangent example again? I'm struggling with it.
Which one? We've done 2.
He didn't say, he just said the tangent example.
Okay, so that doesn't help me.
Okay.
So he's going to have to give us a little bit more information.
Okay,
there.
and then Katlech is asking, please go through how you got the y is equal to 2x minus 2 gradient.
2x minus 2. Okay, so I think that's still, they're talking about the first example, the very first example. All right, I can quickly go over that. All right, anything else?
No, that's about it.
Okay, so guys, I'm quickly going to go over the first example and how we found the gradient of the curve, which is what the question was on the page. I got to 2x minus 2 by taking the equation of the parabola, which is y is equal to x squared minus 2x plus 1, and I derived it using the rules for differentiation. Now remember your power rule, we did this last week. Your power rule for deriving. So if you have y is equal to x to the power of n, right? If I wanted to derive that, I take the power, okay, I'm going to actually put in a constant here, an a. I take the power, I multiply it by the constant, whatever's in front of the x, and then from the power of n, I subtract 1. So that's the power rule. We learned this last week. That's the rule for deriving. It makes deriving so much quicker so that you don't have to use first principles. So that's what I used to derive the equation of the parabola to give me the gradient of the parabola. Because remember, whenever you derive your graph or your curve, you are finding the gradient. So all I did was I did my rule, my power rule. So if I've got x squared, I'm going to say 2 times 1 is going to give me 2. And then from the power of 2, I subtract 1, so I get x to the power of 1. And then the next term, the power of the x is 1. I said 1 times 2 is negative 2. times x to the power 1 minus 1 is x to the naught. X to the naught is 1. 1 times negative 2 is negative 2. And the derivative of a constant is just 0, so that falls away. So that's how I got the gradient of the curve. Remember, whenever you're looking for the gradient of a curve, you need to derive. Your rules for deriving, if you haven't gotten to that at school yet, and if that's why you're getting confused, you've just got to hang on, and you will do it at school. But if you can follow it through the show, that's all we're doing, is we're just using that power rule for the rest of the lesson.
We have one more question from Shikash. He's asking, can you do an example where they give the equation and tell you to find the point of contact?
That's the exact example I've just done.
Oh, all right.
Okay, guys, that was question 1. They gave us the equation of the tangent and they asked us to find the point of contact. So these questions are coming in a bit delayed, and I think it might be that maybe he just tuned in now, so he wasn't aware that we have already done that question. Right. But I'll go through it quickly. If you are given the tangent and the equation of the curve, to find the points of contact, you make the gradients equal. You find the gradients of the tangent, you find the gradients of the curve by deriving, you equate them to each other, and then you solve for x. Okay, that will give you the x value. Once you've got x, you substitute it back into one of your equations, and you find the y point of contact.
All right. Is there Silo's asking if you can show any real life applications for calculus?
We did that last week.
Oh, okay, cool.
Okay, so some of these questions are a bit delayed, and I think I'm going to have to go through them with Luni before I discuss them all on air.
Okay.
I think in the break, and then we'll decide what's relevant to today's show.
All right.
So guys, remember, we are carrying on. This is the second part of the lesson from last week. Last week we looked at all the applications of calculus. We looked at limits, we looked at deriving by first principles, we looked at deriving by rule, and all of that. So if some of you missed that, I think those notes are up on the Facebook page, or from last week possibly. You can go and have a look there. And for today's lessons notes, I think Lenny did say that she's put it up already. Okay, so I don't know, do you want to carry on to another question, or should we go to a quick break?
There aren't any more questions, so we
No,
can
I mean another question.
Oh, you
on
can
the board,
quickly just do one if it's going to take like less than a minute.
No, that's impossible. This is maths. Nothing takes less than a minute.
All right. Guys, let's take a very short break, and then we'll be back right after this, taking more questions and explaining everything. So we'll be back straight after the break. Welcome back, Mindsetters, from that very short break. I hope you guys are refreshed and you're ready to carry on with the lesson. We have something for you here. It's called Curio. It's an application on Mixit that tracks how you're doing in all the lessons from Learn Extra Live and how you guys are doing in all your subjects. So Natasha is going to tell us all about it. So Natasha, what's Curio about?
All right, guys, so you guys know more about Mixit than I do, I'm sure. So you know all about Mixit and how cheap it is and how free it is and all the rest of it. So it's really exciting because it's just another way for you guys to keep in touch with Mindset. And I know you love asking us questions and posting questions and that kind of thing. So it's a really nice app because there are questions already there. And I mean, obviously in an hour, we can't get through every single question you have. So the stuff we've done already, it's on this app. So you simply have to go to Mixit, and you know how to add your apps, but I'm going to go through it with you anyway. All right, so this is if you want to use Curio, and we did, apparently it was introduced last year, so some of you might already know all about this, but it is being reintroduced for those who know nothing. So instructions for Curio, the first thing you're going to do is go to Contacts. Okay, so that's obviously in your contact phone book. Go to your contact. You say add contact manually, and then you enter the ID curio.co.za. So that's curio.co.za. That will be the ID. When you add your contact, obviously it will ask you for an ID. You would then enter that. You then have to enter your username and your cell phone number, and then you'll be asked to confirm. So a confirmation SMS will be sent to your phone, and then you can complete your registration. All right, so those are the first steps. Once you've done all of that, once you've added it as a contact, Curio, then you go to General Apps and open the Curio app. All right, use the code in the SMS. So you will be sent the code that you have to put in. All right, so you'll use the code in the SMS to register on the whole Curio app. All right, so you'll be sent the code. Remember that, hey? And then all you simply have to do is go in, complete an assignment. Like I said, it's going to be questions. We're talking calculus, so this time it'll be all questions on calculus, limits, derivatives, the rest. And you complete an assignment, click on complete the assignment, and enter the Curio code for this week's assignment, which is M12, so M12. Okay, that's the code for this week's assignment. So for those of you who already may have been dabbling with the app last year and you know exactly what to do, maybe just refresh it and reload it, okay? But it's something nice to have on your phone. It is free, which is amazing because you've got all this, you know, maths help and maths practice questions and that on your phone for nothing. And you can complete an assignment. It will tell you if you've got questions right or if you've got them wrong, and you can do them obviously as many times as you want to. So have fun with that, okay? And remember, if you are doing it this week and you're doing it right now while the show is going on, you shouldn't, because you should actually be paying attention to the show. But anyway, the code for this week's assignment is M12. Okay, and I'm going to get back to our lesson for this week. And we are talking tangents and graphs. All right. The most important thing that I've done today, if you've missed everything and you're just tuning in now, those that were paying attention will tell you, most important thing you've learned today is that the gradient of the tangent is equal to the gradient of the curve at the point of contact. We've done two examples. The first one, we looked at finding the equation of the tangent. All right, and in the second one, we were given the equation of the tangent, we were given the curve, and we had to find the point of contact. Okay, so just the two different types. Now we are going to once again go on to finding equation of a tangent. So for those who are a little bit confused about how to do this, we're going to do another question on this. In this question, we are asked to find the equation of the tangent to the graph y is equal to 2x plus 1 squared times x plus 2 at x is equal to 3/4. All right, so let's get started. Now, if we were to draw this, this is actually a cubic graph, which we haven't touched on yet, but it's going to have something to the power of 3. Your cubic graphs are going to look like that, and they're going to look like this. But we will go into more detail as the weeks go on. In fact, next week we might be looking at cubic graphs. All right, but I just want you to keep that shape in mind. Some of you may have seen it before, others may not have. So what I'm going to do is I'm going to expand this expression, and I'm going to get something that's cubic. So remember, 2x plus 1 squared just means 2x plus 1 times 2x plus 1, and then times x plus 2. We have to expand it, okay? There's no short way about it. You've got to expand your equation before we can do anything. So 2x plus 1 squared is going to give me 4x squared plus 4x plus 1. And then I'm going to times that by the binomial x plus 2. All right, and remember, all I've got to do now is just distribute the terms from the second bracket into the first bracket. All right, so x times 4x squared is going to give me 4x cubed. 4x times x is going to give me 4x squared. 1 times x is just going to give me x. Okay? Next, we're going to times the 2 into the bracket, so times it by every term. Okay, 2 times 4x squared is going to give me plus 8x squared. 2 times 4x is going to give me plus 8x. And then 2 times 1 is just going to give me 1. We add our like terms. So we get 4x cubed plus 12x squared plus 9x plus 2. So as I was saying, you see we get a cubic expression, and a cubic function looks like those two graphs. You don't have to really worry about this now. I'm going to go into much more detail in the following weeks. All right, but we are asked to find the equation of the tangent to this graph at the point x is equal to 3 over 4. So this is what's happening. We've got one of these graphs, and we have a tangent that's just touching it at a point, and all they've given us is the x coordinate at that point. So we know that x is 3/4, but we don't know what y is. Okay, and they want to find the equation of this tangent. All right. Now remember, once we've simplified all of this and we've got our expression out, we need to find the gradient of the tangent. Okay, because remember your equation of the straight line is y is equal to mx plus c. So you need to find the gradient of the tangent. Okay, and how are we going to do it? We've only got the equation for the cubic function. So how do I find the gradient of the curve? Hopefully you all realize by now to find the gradient of the curve, you derive. So what I'm going to do is I'm going to derive this expression, and that's going to give me the gradient of the curve. Okay. So using the power rule, remember if you guys are getting confused with the power rule because you haven't done it, you will eventually get there at school. Okay, but it's the quicker way to derive without using first principles. So we take the power, times it by the constant in front of the x. 3 times 4 is 12. From the power of the x, we subtract 1. So 3 minus 1 is 2. Okay? For the next term, we do the same thing. Power times the coefficient. 2 times 12 will give me 24. From the power, I subtract 1. So 2 minus 1 will just give me 1. All right? Next term, the power here is 1. 1 times the coefficient of 9 is just 9. From the power of the x, we subtract 1. 1 minus 1 is 0, and we get x to the 0. But x to the 0, remember from exponents, is 1. So therefore, I don't need to put anything next to the 9, because 9 times 1 is just 9. The derivative of the constant 2 is just 0, so we leave it out. So this gives me the gradient of the curve. If I want the gradient of the curve at the point 3/4, all I do is I substitute 3 over 4 in place of x in the expression for the gradient. That will give me, importantly, the gradient of the tangent as well, because remember where the tangent meets the curve, the gradients are the same. So if I use this 3/4 and I substitute it into the curve, into the gradient, I will get the gradient of the straight line at the same time. All right. So let's do that. We're going to say 12 times 3 over 4 squared plus 24 times 3 over 4 plus 9. Okay, this is going to give me 12 times 9 over 16 plus 24 times 3 over 4. 4 goes into itself once, 4 goes into 16, into 24, 6 times. So 6 times 3 is going to give me 18 plus 9. If you want to, you can use your calculator here. All right. 12 and 16, 12 times 9 over 16. Let's simplify. We get 4 goes into 12 3 times, and 4 goes into 16 4 times. 3 times 9 is going to give me 27 over 4 plus 18 plus 9 is 27. So I'm going to get 27 and 27 over 4. All right, and you can use your calculator. I think this is going to give you like 28 comma something. All right, you can check that on your calculator. Unfortunately, I don't have my calculator up at the moment, so I can't give you the decimal answer to that. But it'll be 28 comma a few decimal places. All right, so what have I found? Okay, and it looks kind of strange, but what I've found is I've found the gradient of the curve at the point of contact. Okay, so the gradient of the curve at the point of contact is going to be 27 and 27 over 4. All right, now that we've got the gradient of the curve, remember the gradient of your tangent is going to be exactly the same. Okay, so therefore the gradient of your tangent is also going to be 27 and 27 over 4. So this straight line here, the yellow one, we know that M is 27 and 27 over 4. All right, guys, I don't like working with it in a fractional form like that, so I think what we're going to do is go through a quick break while I try and get the calculator up.
Okay, guys, we are going to take a very short break, but then I'd just like to tell you guys about that Curio app. It is Mix It, and then all you need to do is follow all the things that Natasha went through during the show. So guys, we are going to take a very short break, so hope you stay tuned. Welcome back, Mindsetters, from that very short break. I'm so sorry about that very confusing link to ad break before the break. So what I was saying is that we do have a Mix-It app. It's called Curio, and Natasha was going through all the instructions and all the stages you need to take and everything that you need to do on your Mix-It in order to have the app on your phone. We did post the link on our Facebook page and the instructions and all the information that you need for Curio. So all you need to do is go onto our Facebook page. It is facebook.com/learnextra, and you'll get all that information about Curio and everything else that we've been going throughout the show on our Facebook page. Tweet us at LearnExtra, and as well as download all the show notes, learnextra.co.za/live. That is the website where you get the show notes, the schedules, and the videos. And with all that said, I'll take it straight back to Natasha again.
All right, great, guys. So remember, we took a break because I needed to find the calculator and I couldn't do decimals in my head. Okay, so I've got the answer now, but I just want to go through with you what I've done so far. So if you've just tuned in, then we are in the middle of the example. So I just want to go through what I've done so far. We were asked to find the equation of the tangent to the graph at the point x is equal to 3 over 4. So what I did is I took the equation that they gave us of the graph, I multiplied it all out, and I got an expression, a cubic expression. Okay, we got this expression, 4x cubed plus 12x squared plus 9x plus 2. All right. I then, because I said, well, we need to find the gradient of the straight line, so therefore we know that the gradient of the tangent is equal to the gradient of the curve at the point of contact. So I derived the gradient of the curve, because remember, when you derive that, you get the gradient. So I derived that. I got 12x squared plus 24x plus 9. And then I substituted the point of contact, which was 3 over 4. All right, I substituted 3 over 4 in place of x, and I simplified it all without a calculator, and I got to 27 and 27 over 4, which was really not looking very nice. So I simply, on my calculator, took that, and I said, what is that as a decimal? And we got 33,75, okay? And we can write it, obviously, as a mixed fraction as 27 and 27 over 4, or as an improper fraction as 135 over 4. You can leave it in any one of these states. Okay, so now that we've got the gradient, remember, this is now the gradient, as nasty as it looks. It is the gradient of the straight line. So the gradient of the straight line is going to be 135 over 4. And then obviously we times it by x and we add our c on. So this is now the gradient of the straight line. We still need to find c. Now in order to find c, we need to know what the y value is at the point of contact. Remember, all we've got is 3 over 4, and we don't know what y is. Okay, So if I want to find the y value, I simply need to use my equation, which was given to me as y is equal to 2x plus 1 squared times x plus 2. So I'm simply going to use that equation because obviously it's the only one we've got to work with. So it was 2x plus 1 squared times x plus 2. I need to find the y value that corresponds with an x value of 3 over 4. So all I'm going to do to find that coordinate is I substitute 3 over 4 in place of x in the original equation. And let's see what we get. So it's going to be 2 times 3 over 4. You can put it in this form where we haven't expanded, or you can put it into the expanded form. It really doesn't matter where you put the 3/4 in. So I'm going to get 2 times 3 over 4. 2 goes into itself once, 2 goes into 4 twice. So we're going to get 3 over 2, which is 1.5 plus 1. So we get 2.5, hey, which is 5 over 2 squared times 3 over 4 plus 2, which is 2 3/4. Alright, so we're just going to do that on the calculator, or you could obviously put everything on your calculator and just see what you end up with. So we've got 5 over 2, and we're going to square that, and then we're going to times it by 2 plus 3 over 4, and that's going to give me 275 over 16. As you can see, guys, the answers aren't really nice, pretty 1s and 2s and 3s. These are fractions, and it's real life. You get fractions and you get decimals. Alright, so therefore our y coordinate is 275 over 16. So our point of contact is now 3 over 4 and 275 over 16. Okay, so what did I do? I used the 3 over 4, put it back into the equation of the cubic graph. That helped me to find the y coordinate. Once now I've got the y coordinate and the x coordinate, and remember before we saw that the gradient was 135 over 4, I can find the y-intercept by substituting everything back. So it now looks like this. Y is equal to mx plus c. Remember, it was y is equal to 135 over 4. And remember, in place of x, I've got 3/4. And in fact, I'm going to replace y with 275 over 16. And I simply need to solve for c. So c is going to be 275 over 16 minus 135 over 4 times 3 over 4. Obviously, you can do all of this on your calculator, which is the best way to do it. All right, because we're dealing with so many fractions. So we've got 275 over 4 minus...
Isn't it over 16? 275 over 16.
Did I make a mistake, Looney?
Yes.
It is quite possible.
So you had
275 over 16.
as
Oh,
your
yay,
y.
someone is awake. Well done. All right, and that might just mean that we're not going to have time to finish it, but we'll check. And it's going to be 135 over 4 times 3 over 4. And that gives us minus 65 over 8. Okay, so therefore our equation, and we can end it off nicely, is y is equal to 135 over 4x minus 65 over 8. So it's 135 over 4 times x minus 65 over 8. And that is the equation of your tangent. It doesn't look very pretty, but sometimes you don't get equations that work out beautifully. All right, so guys, the one thing I want you to take out from this lesson, obviously remember to download our app onto Mixit, our Curio app, but also I want you to take out that the gradient of the tangent is equal to the gradient of the curve, at the point of contact. That's what today's lesson was all about. All right, thanks.
All right, guys, you heard all of that. Remember, guys, we are also human, so we'll make mistakes sometimes. We'll say things that don't make sense, and you're like, what is Looney saying? What is Natasha saying? But guys, remember, we are human, so we make mistakes, and we apologize for that. But remember, we do rectify mistakes, and everything goes smoothly. Thank you so much for tuning in and for joining us on Facebook, on Twitter, and for downloading the notes, guys. It will help you at the end of the day. So we're doing all of this to help you. So thank you so much, guys, for joining us. You guys have been great on the page. And we'll see you same time, same place next week, Monday, guys, with more maths. Remember to learn more and learn extra.